So then on the center by kinematics, d is v0 times t, h is 1/2 gt squared, that's correct. So t is 2h over g square root, d is v0 times as much, that's good. 2, without friction, resulting velocity, because stick to is perfectly inelastic, that's good. Conservation of the momentum, final velocity, so we have m1 times v0 equals to m1 plus m2 times vf. So vf is this. Okay, well, let me see, m1, m2, okay, mostly good, but here's one of my questions for you. Think about this. When you see, let me draw it out. Actually, you see, this is what do you call toboggan? I don't know what. You see, when the mass is hitting the toboggan, what exactly is the velocity? Is it going to be something like this, right?
Yeah.
Because it's a projectile motion. So which means that if I were to use the conservation of the momentum, you see, then I would have a bit of a dilemma. I have you see, I have a v0 over here, but I do have a vy over here, which means I have the total velocity, as a combination of the two. But how should I proceed with the conservation of the momentum in this? What should I do about this vy?
You can split the conservation of momentum into individual x and y parts.
Okay, so does that mean that? Well, does that mean that okay, you're covering the horizontal direction, but the vertical direction, the both object would have a vertical velocity?
No, because it's like on the ground, so there's a normal force.
Then where's the catch? Why is the normal force impacting the vertical direction conservation of momentum?
Because the normal force gives like impulse vertically.
Okay, yeah, mostly that's right. Yeah, that's actually right. That's actually right. But yeah, so what I'm trying to say is, over here is pretty much correct. Just need to emphasize that the conservation of the momentum is only in horizontal direction. Right? Because actually in the vertical direction, we don't have a conservation of momentum y. And another thing you should mention is vertical direction, you have a non-zero external force, right? Because only with zero external force, you should have conservation of, conservation of the momentum, right? If you have non-zero, you shouldn't. That makes sense? So that's why we don't even think about vertical direction. The velocity just gone. And what you said is actually correct. It's being just wiped out by the vertical direction impulse caused by the normal force from the ground. That's correct. Okay. So yeah, this is just a little minor thing. It may not even come up if you give the this solution. Well, I would say 90% of the chance you should be able to get a full mark, but there's still 10% of the chance they're expecting you to just provide a little bit of description why in the vertical direction we don't need to worry about this. Okay, so that's fine.